All right, so with this book, we have some conventions for numerical estimation. So when we're estimating things, we have some conventions we're supposed to follow. So when we're using a numerical estimation to investigate a limit, what it goes to, in this text, basically we're going to increment input values by either adding or multiplying by a constant until we see a pattern apparent in the output values, okay? So in a simple pattern such as 999 or 0001 appear, we use at least 4 estimates to establish the pattern. And so what we'll do is we'll use one number for an input, and we'll come up with an output. We'll use another one, we'll come up with the output. We'll use another one, we'll come up with an output. We'll use another one, we'll come up with an output. And that way we know that, hey, yeah, we really have reached some kind of a pattern. It's going to, all these nines, or it's going down lower and lower and lower, okay? Now, when the output values do not form a simple pattern, they're just jumping all over maybe, what we're going to do is we're going to show 2 more decimal places than the accuracy required. So say we want it to the ones digit, then we'll put 2 decimal places after that, okay? And then we're going to use as many estimates as necessary until the output values remain constant for 3 times. So it has to be 3 times the same, and then we can stop. And another one is at times the output value appears to increase or decrease without bound. And so here we're going to use at least 4 estimates again, kind of like we did on the first one, to establish the pattern of unbounded growth or decline. So it's either decreasing to a very, very small number or going very, very large growth. So what we're going to look at here is we're going to look at the output values for f of x equals x over x plus 1 as x increases without bound. Okay, so we're going to increase it without bound. Now, the further out we go, the closer to 1 we're going to get. We're going to see. Okay, now this is a concept known as the limit. And see, this business calc, that's how we're going to work at things. We're just going to say, yeah, this is a limit. We're not going to prove it. We're not going to do anything. We're just going to start using limits. Okay. Now note it doesn't never equal 1, it just approaches 1. So it gets very, 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 very close. Depending on how many decimals you want to go out, thousands of decimals, it's going to still be close, but it's never going to actually reach that 1. Now this is the case for decreasing without bound as well for this exact function. And so what we can see is if we use x and we're going to go all the way to positive infinity, and what we're going to get out is our f of x. That's going to be our output. If we plug in 1 up here, that's going to be 1 over 1 plus 2, which is 2, so 1/2. Now, if we plug in 10, we'll have 10 over 11. And if we divide that, we get 0.0909, and then we round it to that decimal there. And we plug in 100, and it just keeps going. And we 1,000, 10,000, 100,000. And as further and further we go, we can see that it's getting closer and closer to 1. And so we would say the limit of f of x as x approaches infinity, or as we increase x without bound, it's approximately 1. Okay, so as we keep going further and further to the right for x's, it's going to approach 1. Now, what happens if we approach negative infinity? So go the other way. So this time, instead of going this way for x, we're going to go this way because we want to go to negative infinity. Well, we do the same thing. We start with -1, and guess what? You can't do it. -1 plus 1 is 0. You can't divide by 0. So make sure you have something undefined if it's undefined. So you have that asymptote, that vertical asymptote at that point there, okay? Then we plug in -10, okay? So when we do that, we get 1.111. Then we plug in 100. Now we go to alternating zeros and ones. Plug in 1,000, we get 1, 2 zeros, 1, 2 zeros, and so on. And then we plug in -10,000, we get 1, 3 zeros, 1, 3 zeros. But we're only going out to the 5 decimal places, so that's what it would look like there. And then if we plug in a -100,000, we're even closer to the 1 than we have been. So we can see we're approaching that 1. And if we go out even further, it would put a 0 here, and that's as far as the decimal places go. And so as we approach negative infinity, that f of x is approaching 1 here as well. All right. Now, the numerical estimation, the process of estimating limiting behavior by evaluating increasing or decreasing values of the input value. Okay, so that's what we're doing. We're doing a numerical estimation by plugging in values, and then we're estimating what it's going to go to. All right, so like I've kind of read this before. The following is read as the limit of f as x increases without bound is 1. Okay. So limit of f of x as x approaches infinity is equal to 1. Or the limit of f of x as x decreases without bounds, so it goes to negative infinity, is also 1. Okay. Now the limiting value, that's when the function approaches a number L as the input increases or decreases without bound. That's the limiting value. And as we notice, we're approaching 1 and we're approaching 1. So 1 is going to be our limiting value. And what we see then is the horizontal line that has the equation y equals L is our horizontal asymptote. And so in this case, y equals 1 is going to be a horizontal asymptote. And we can see that in the next picture on the graph. So we've basically graphed x over x plus 1. And so we're going to have this part and we're going to have this part. And if we plug in that y equals 1 here, we can see that as we approach positive infinity, we get close to 1, and we're from the lower side. And here, as we go to negative infinity, we're approaching 1 from the top side. And again, we never reach that 1. We get very, very close, though. Okay. And so we're just approaching that dotted line from either side. We're approaching it from the bottom as we go up to positive infinity, and we're approaching it from the top as we go down to the negative infinity. All right, so some limits and end behaviors. So the notation, the limit of f of x as x approaches either positive or negative infinity is equal to L, means the output value has that limiting value of L, okay, as the x increases or decreases without bound. And so what we can see here in this case, when we go left or right, we're approaching this one as we're approaching negative, or the 0.5, not negative, it's approaching 0.5, whether we go to x going to the positives or as x is going to the negatives. And this is what we see. So the limit of f of x, whatever this function is equal to 0.5 as x approaches positive and negative infinity. And this time we're approaching them both from the bottom. Now, the notation, the limit of f of x as x approaches positive or negative infinity is equal to infinity, and negative infinity means the output values of f of x do not have a limiting value of L as x increases or decreases without bound, but instead either increases or decreases indefinitely. So two possible examples might be this one. So in this case, as limit of f of x is x goes to negative infinity, that goes to positive infinity. So as we go to negative infinity, we see that this is just going to go on and on up to positive infinity. But limit of f of x as x goes to positive infinity, that goes to negative infinity. So as our x goes to positive infinity, our output goes to the negative infinity. And the same thing goes with the straight line, okay? So it doesn't matter what straight line. In this case, our line is positive slope. And so that means as we take the limit of f of x as x goes to negative infinity, we get negative infinity for our limit. And the limit of f of x as x goes to positive infinity, it is going to be positive infinity because it's just going to keep going up without bound. Now, what happens if we have, say, a negative slope? Well, then f of x, the limit of f of x as x goes to negative infinity, well, that's going to be positive infinity. And as x goes to positive infinity, the limit of f of x as x goes to positive infinity is going to be a negative infinity because it's going down and down, okay? So those are how some limits and end behaviors work. And again, we're taking the limit of x as it approaches positive and negative infinity, strictly negative, strictly positive, strictly negative, and strictly positive again. All right, so that's the end of that part, and I'll come back for a little bit more.